In this video series, we'll be discussing antiderivatives, or the reverse of a derivative. So instead of having a function and finding the derivative, I will be giving you a derivative and we'll be finding the original function. Now within this, we will have a little bit of an issue because the derivative of any constant is 0, so every function will lose its y-intercept. So we're going to have this constant of integration that's going to have to be put at the end of each piece. So let's look at an example. We have the differential y prime equaling 2, or dy dx equals 2. So to find the antiderivative, we need to move our dx over and integrate. The integral symbol is kind of like a stretched out S. I will get into why we use that notation for an integral later on in another video series. But just know for now, when you see the stretched out looking S symbol, that means integrate or antiderivative. So if we have technically a 1 dy, then we know that we started with a y because the derivative of y is 1 dy dx. So we have y equaling the antiderivative of 2 now. So you took the derivative, you're left with 2. That means you had to have had 2x originally, and then plus a constant of integration because you're not sure what your y-intercept was. So let's look at this graphically. So I have a graph and I've typed in our antiderivative, y equals 2x plus c. And then when I push play, that kind of shows you what that constant does. As you already knew, it's going to shift the function vertically or up and down depending on what c is. So that's the importance of the constant of integration. So if you forget it, you will lose a decent amount of points. So please make sure that you remember the constant of integration. But then your final answer is y equals 2x plus c, unless you're given additional information that will allow you to solve for c. And we'll eventually get into that. That's called the particular solution. Right now we have the general solution. So we have the integral, which is really telling you to find the antiderivative. Dx tells you with respect to x. Because eventually in other calculus courses, you could actually find the antiderivative with respect to a different variable than what you're integrating. That's later on, but just know that that is the case. And then you get your antiderivative plus c, the constant of integration. Please note that it is important that we have both a lowercase f and a capital F. So the lowercase f is the function we're going to find the antiderivative with respect to whatever variable they tell us. And then capital F of x is the antiderivative of that function. So please note that there is an important piece between those symbols. Hopefully that makes sense. So then the antiderivative of a derivative is just the function itself. So we have the antiderivative of the derivative, and that is just the initial function itself plus c, which hopefully makes sense. So then, the derivative of an antiderivative, well, if you find the antiderivative and then you differentiate it again, that'll leave you with f of x. And that's because if you take the derivative of this piece, so d dx of the antiderivative plus c, well, c goes to 0, and the antiderivative goes back to the initial function you integrated within itself. So that's why it's equal to f of x. And there will be a theorem for that later on that'll have a little more significance because it'll have bounds. So then we're going to find the antiderivative, and we're going to actually come up with like a little formula like we had for derivatives. So we're going to integrate 3x dx. So we're reversing the process. We have 3x dx right now, and we need to figure out what we started with. Well, we have an x, so that means we originally had an x squared. And if you think about the process of a derivative, you would multiply by that exponent, but we're reversing the process, so now you would divide by that exponent, and then you can't forget the constant of integration. So in general, the integral of x to the n dx is equal to 1 over n plus 1 to the x to the n plus 1 plus c, the constant of integration. So that is the generalized process for finding the antiderivative of something with an exponent. So you want to kind of think that through and make sure that you're comfortable with that. If you need to put that in your little notebook, please do so. So just like we did with derivatives, we're going to take some time and rewrite, find the antiderivative, and then simplify. I think I will cut this video and start a new one for this process. Thank you for taking time out of your day to watch this. Please continue the series.